Now that we've done a really good job of deciding whether something is a function or not, we need to jump into function families. So it's what kind of function is this? Okay, and we call them families because they're made up of a family. Okay, so there's 4 different function families that we're going to talk about right now. There's lots more, but these are the important ones for Algebra 1. The first one is we have a linear function, okay? And that parent function is y equals x. And it's graphed like this because for every 1, for x value being 1, y value is 1. We call this the parent function because this is where it starts out. Then we make some transformations on that. And we'll talk about the transformations here in a minute whenever I introduce all the parent functions. So this is the most basic linear equation that you could have, y equals x, and that is the graph of it, okay? You might have your graphing calculator available. There's a couple applications online where you can use a graphing calculator, or you can also download apps on your phone to use it. So if you graph y equals x, this is the graph that you would get, okay? Now our second function family is our quadratic, okay? The parent function is y equals x squared, and it looks like a parabola is what we call this U-shaped graph. Because we're squaring all the numbers, they're going to be positive, okay? And then we have cubic, when our parent function is y equals x cubed. And whenever you cube a number, it's not always necessarily positive, so we do have some negatives, and it looks like this shape right here. Then our fourth function family that we have is our absolute value. The parent function is y equals absolute value of x, and it is a straight V-like shape as a graph. Okay, so these are all the original graphs that come out of these families. Now, whenever we start adding numbers, subtracting numbers, multiplying by numbers, then that's whenever there are some transformations and it moves the graph around, okay? So we're going to look at the linear transformations, okay? Here's our original parent function, y equals x. If we add a number to it, that will move our parent function up on our graph, okay? If we have y equals x and we subtract a number from it, that will move our parent function down, okay? And then if we have our parent function and we multiply it by a number, it's going to make it steeper. And then if we multiply it by a fraction, it will make it more shallow. One more piece of information you need to know is that if it is a negative multiplication or a negative here, it flips over the y-axis. So this whole entire parent function would flip and it'd be backwards like this. So that is if it's a negative. Okay? All right. So those are the transformations for linear, 4 simple transformations, and they can be a combination of addition, subtraction, and multiplication. You can put those together. Okay, we'll look at some examples here in a second. Okay, our next function family, quadratic, has 6 different transformations, and then it also has one more that I'm going to put up here. You can either add or subtract a number inside the exponent or outside the exponent. Okay, so if you add a number to the parent function outside of x squared, that's going to move our quadratic formula, our quadratic graph up. Okay, so sort of kind of the same as linear. Now, if we subtract a number outside, it's going to move it down. Also the same. It gets a little tricky when we start adding numbers inside the square. Okay, so if we square and we add a number inside the square, that's going to move our parabola to the left. And if we subtract a number inside the square, that's going to move the parabola to the right. Okay? And then we have our multiplication, and it's all about the same idea. If we multiply by a whole number, it's going to make it skinnier. If you multiply by a fraction, it's going to make it wider, so the parabola can get wide or small. And then if we have our negatives, if you multiply by a negative number, it's going to flip over the x-axis this time. And our parabola will be flipped down. So these rules right here for a parabola actually apply to cubic and absolute value also. So you have a set of 5 and 1, 2, 3, 4, 5, 6, 7. You have a set of 12 rules that you need to remember for transformations, okay? These will start coming easier when you start looking at graphs that have been transformed. Okay, so I have a couple examples up here at the top, and I want you to be able to name what family it is in and the transformation that has taken place. So we have y equals x plus 4. You recognize that y equals x is our parent function, so that therefore is a linear function. And then we added 4, so when you add a number, it moves it up. So we've gone up 4 with that linear equation. Okay? Here's another example, y equals 1/3 x minus 7, okay? X is a linear equation, okay? If we multiply it by a fraction, it's going to get shallower, so it's going to fall a little bit like this, and we subtract 7, so we move down 7. So this has become more shallow and moved down 7. Okay? Our next one, y equals x minus 4, that whole thing squared. Okay, anytime I see some kind of something squared in a function, I recognize that that is quadratic. It is inside the parentheses, so I wrote that wrong. If it's inside the parentheses, it moves to the right 4. Okay? And this one is a lot of things combined together, okay? So first off, we see that it's to the 3rd power. That means it's cubic, okay? We follow these same rules here. So we have a subtraction outside of the parentheses, so that means it's going to move down 2. We have addition inside the parentheses, so that means it's going to move left 5. And then we're multiplying by a positive number outside, so that becomes skinnier, okay? I have 2 examples down here for you to try on your own. Tell me what function family it is, and then also tell me what the transformations have taken place. Okay? Take a minute and pause the video, and whenever you come back, I'll have the answers here. Okay, so I recognize that x has an absolute value around it, so then therefore this function family is absolute value. Okay, I'm following the same rules as this, so the 3 is outside of the absolute value, so I'm adding 3, that means it's going to move up 3, and I'm taking a 1/4 of it, so that is going to make my absolute value wider. And then this one, we have something to the 2nd power, that means it's quadratic. We're adding 7 to it, and that's outside the parentheses, so that means it's going to move up 7. And we're multiplying by 3, so that is going to be skinnier. That concludes the function families and transformations on functions.